Okay, so next up we have Lane Rettig, core developer at Ethereum Foundation, and he will be talking about Ethereum 1x roadmap and maybe a Q&A session if we have time. There we go.
Thank you. All right. I'm guessing the big green button goes forward. Cool. Hey guys, I'm Lane. I'm on the Ewasm team, and I'm pretty excited to share with you guys a little bit about what some folks are working on as part of kind of a broad project called Ethereum 1x. You've heard quite a bit the past few days about Ethereum 2, right? Ethereum 2 is awesome. It's like super exciting. It's going to bring us to the glorious future of scalability and proof of stake and all that cool stuff. But we need to kind of keep in mind that we kind of have this existing legacy blockchain, right, running today. And so Ethereum 1x is, broadly speaking, it's sort of not a single monolithic initiative. It's kind of a collection of different initiatives being spearheaded by a few different groups to kind of push the existing Ethereum blockchain to its limits and keep it healthy and just kind of add as much functionality and scalability to it as we can while we wait for ETH 2. So let's kind of dive in and take a look at it. Kind of kicking off briefly by way of background, as I'm sure most or everyone in this room knows, Ethereum has been running since 2015. We've had the most recent couple of network upgrades in 2017, and then most recently a couple months ago were Byzantium and then Constantinople. The point here on this timeline that I want to highlight the most is June 2018. And Danny spoke about this a couple of days ago in his awesome overview of ETH 2. So up to that point in time, the kind of Ethereum 2 roadmap consisted of two separate parts, right? So that was sharding and Casper. And they were two kind of parallel work streams. And the decision was made at that point in time in June of last year that actually these two work streams should be merged into a single work stream, which is now kind of what has become the canonical Serenity or Ethereum 2 roadmap. And as Danny explained, it was kind of like one step back in order to take two big steps forward, and it was a difficult decision and a big decision. Now in retrospect appears to have been like the right decision, but there's some interesting kind of knock-on effects that this has caused, and one of them is kind of a reevaluation of this question of what should we do with the existing Ethereum blockchain while we wait for ETH 2. Up to that point in time, so kind of prior to June 2018, the general thought had been, let's not try to get too fancy or do too much innovation in the existing Ethereum blockchain because ETH 2 is around the corner, right? We kind of expected to see things like Casper FFG launch as early as like late last year, and obviously now that's been pushed back a bit. And so that's kind of what gave birth to this Ethereum 1x initiative. So, it's interesting, right? I think if you think about Ethereum as sort of kind of like a startup or like a new piece of technology, every startup and every piece of technology that's built faces this sort of fundamental challenge, right? You kind of build something lean, you build something kind of crappy in the beginning that's kind of held together with like rubber bands and bubble gum. And some people start using it and some more people start using it. And before you know it, you like have this sort of prototype, let's say beta implementation that kind of works but is kind of broken, right? And in our particular case, existing Ethereum is great, but like it doesn't really scale, and we're not in love with proof of work and things like that. And so then you kind of find yourself in this situation where you have to decide, right? Do we continue to like bolt on new features and to try to patch and maintain the existing product, or do we like scrap it and rebuild it from scratch, right? As I said, this is a challenge that like every tech startup and every new tech project faces. So, for better or for worse, we have real people and real projects and real value on the line in our existing Ethereum network, which is awesome, which is exciting. But it also means that we can't kind of completely throw it away wholesale and just start totally from scratch. And so we're taking what I believe is the right approach, and that's sort of two parallel work streams, right? So on the one hand, we have, again, this exciting research happening on ETH 2, and ETH 2 really is mostly from scratch, kind of a reimagination of what Ethereum could be, keeping the good parts, kind of throwing out or upgrading the parts that we don't like as much. And ETH 1x, which is happening in parallel, as I said, is the sort of example of just improving what we've got. And while they're happening in parallel and they are distinct and there are largely kind of separate groups of people and teams working on them, the most important point I want to highlight here is that most, or hopefully all of the work that's being done today on ETH1X will inform or sort of flow directly into ETH2. A great example of this is the work that's being done on things like storage management fees and state rent and that kind of stuff, which we'll talk about in a sec. That stuff will need to flow into ETH2 anyway. So there's kind of no, I don't believe any work is being wasted here. So yeah, we only have 15 minutes. This is sort of a big complex topic, so we'll just kind of scratch the surface, but I'll just tell you a bit about what it is, about why it's important, about what actually is going to go into it, and then about how it fits into the broader Ethereum roadmap. So this is how Ethereum 1x was born. So this is DevCon 4. This was October, November of last year in Prague, and this is an ad hoc meeting among a few different groups of sort of core developers and researchers. So we have kind of folks from the Ewasm team and the Parity team and the Geth team and some other teams who are sitting on the floor at DevCon saying, hey, you know, scratching our heads, discussing kind of the implications of that change that I said happened in June of last year when ETH2 came together and the sort of roadmap was pushed a little bit, discussing kind of our strengths and weaknesses and what we can do better. So the other point I want to highlight about ETH1X is that, you know, we kind of use this hashtag or this brand ETH1X for simplicity and for legibility, but it's not in any way, shape, or form like a single initiative. There's no like single roadmap. There's no single person or single team responsible for it. I think a better way to look at ETH1X is really, it's just everything happening in parallel to or aside from ETH2, right? It's just kind of all the cool stuff that we're going to be able to do in Istanbul and other upcoming hard forks in parallel to the ETH2 work. So really interesting question, right? Why do we need it? Why not just maintain Ethereum as it is and just focus all of our resources on ETH2? So from the very beginning, there's been this vision that Ethereum should be decentralized, right? And to be very clear, like, this is our differentiator to me. This is one of our big differentiators. We will not sacrifice decentralization, and we will not sacrifice things like censorship resistance at any cost, right? These are non-negotiables for us. And so the vision has always been that you can run an Ethereum full node on a piece of commodity hardware like a laptop. I have this laptop, and I run an Ethereum full node on it, and it's kind of hard, right? It's possible. I do it. I you know, have a kind of dodgy Wi-Fi connection in my Airbnb here, and it's been struggling, but it's like sort of keeping up, right? I think I'm still at the head of the chain. But it's kind of pushing the limits of like what's possible with commodity hardware. So, you know, this is a laptop that has 32 gigabytes of RAM. It's a laptop that has a very fast SSD drive in it. Obviously, it helps if you have a more stable internet connection, a faster internet connection, et cetera. And if you don't have one or more of those things, it's tough. You know, it tends to chew up something like 4 or 5 gigabytes of RAM. As I said, it often kind of gets behind and loses the head of the chain and struggles to keep up. And in some cases, if you don't have an SSD drive, you can't keep up at all. So, you know, the point here is as the Ethereum blockchain continues to grow, as more transactions flow through, as the state continues to grow in size and balloon, it's going to become harder and harder and harder to keep up with commodity hardware. And the flip side here is if we don't tame it somehow, if we don't do things like bounding the size of the state, then we will have a lot less nodes. And in fact, the number of nodes has already fallen from something like 30,000 at the end of last year to, last time I checked, around 9,000. So cool, let's dig a little bit deeper into ETH1X and just talk about the different pieces of it that are on the table right now. So the first, and I think probably the core and the most essential piece of it really is bounding the growth of the state. So this graphic comes from a gentleman named Alexei Akunov, who has been working on a project called TurboGeth for the past couple of years. And so he's been doing a just enormous amount of work on ETH1X. And so a lot of kind of the numbers and figures I'm going to show you here come from his work and the work of a couple of other people. So this is as of a few months ago. This is the number of storage items in the Ethereum mainnet state. And there are different dimensions you could use. You could look at number of transactions. You could look at gas being spent. But I find this one quite interesting because it really speaks directly to the computational burden of running an Ethereum full node more than some of the other figures do. You know, when we talk about the cost of running a full node, people tend to always focus on things like disk space size. And it's not small, right? It's something on the order of 100 gigabytes that you need today to run an Ethereum full node, right? Which downloads and fully processes and fully validates all the transactions in the network, all the blocks. But again, when we dig deeper, it's actually less about sort of sheer number of gigabytes and much more about things like the number of storage items, which is on the order of 140 billion, I think, a bit higher by now. And just to put things in perspective, when I synchronized my last full node, it took about 2 weeks. And most of that time is not spent downloading data. It's not really about disk space. It's really about processing and chewing through all those transactions. Next topic is stateless clients. So this is sort of a recent addition to ETH1X. And it's directly related to the previous item, to bounding the size of the state. So there's a couple of approaches we can use to bounding state, right? The one approach is something like storage management fees, where people have to lock or pay Ether in order to use more storage slots, because storage is underpriced right now, since we only charge once for it. We don't charge over time. Another more radical approach is this concept of a stateless client. And this is also from Alexei. So a stateless client is a really elegant solution to this problem, which takes the burden of storing state off of the nodes and puts that burden on the users, right? So when you submit a transaction, rather than relying on the fact that the full node has the state and can find it and update it, you, as a user submitting a transaction, have to store that state, and along with your transaction, you have to submit a Merkle proof, actually one per storage slot that you're updating. And it's elegant, right? But it places a burden on the users to download and store the state. Also, there's a cost associated with these Merkle proofs. We want them to be as succinct as possible, because you're going to have to pay per byte for those. And so there's some technologies that will help with that. And there's also like user experience implications here as well. It may be difficult to store state in, on, let's say, a mobile device or a mobile wallet or something like that. So this is cutting edge research, but if it works, it's exciting and, again, very likely to inform some of the ETH2 design decisions. A third topic is something called pruning chain data. So the actual transactions are one piece of data that is stored and processed by the nodes, but there's other data. So this is things like the blocks themselves, the headers of the blocks, the logs and receipts, right? Things like that. And so this is a project that has been spearheaded by Peter Szilagyi on the Geth team. This comes from his proposal. And the nice thing about this is if we're able to prune some of this data, unlike pruning the state size, this does not require a hard fork, right? This is not a change to the protocol. This is more just a change to the way that the clients are built and run. And for that reason, it's a little bit easier and a little bit less controversial. It doesn't require paying for things like rent or storage management fees. If you see here, right, so receipts and block bodies and headers and things like that, the shape of these graphs is very similar to the graph I showed you a moment ago, the state size rather. So this is happening in parallel, and again, I think that this could give us some pretty exciting gains. Another parallel workstream here is Ewasm. So this is the project that I'm a part of. Again, huge, complex project. I'd love to talk to you more about it. In a nutshell, it is a better, reimagined state execution engine, a virtual machine for Ethereum, right? Both for ETH2 as well as for ETH1X, that's based on this rapidly emerging and just very exciting global standard called Ewasm, which stands for WebAssembly. So Ewasm is a project of the World Wide Web Consortium, so it's very broad, has a lot of global support from companies like Google and Microsoft. It exists already in pretty much every major web browser in the world, and we're kind of tweaking it by adding some Ethereum functions to it and adding metering and things like that. It's not really a core essential part of ETH1X per se. It doesn't help directly with like reducing the computational burden on the nodes. But what's nice about it is that if we're going to do things like making storage more expensive, it'd be very nice to then make computation cheaper. So it's kind of offering developers a trade-off. And so the most active area of research right now in Ewasm is figuring out how much we can do that, how we get there, basically, and how we do so safely. And the final work stream in ETH1X is simulation. So this is being spearheaded by a gentleman named Zach Cole, who, I don't know, maybe out there somewhere, and his company, which is called Whiteblock, which very kindly open sourced some software that they've been working on. And they've done analyses for a number of blockchains, including EOS and Ubiq. I believe these images here come from a report that they published on the Ubiq blockchain. And the idea is if we're going to make these changes, if we're going to do things like introducing storage rent or trying to bound the size of the state, what kind of actual concrete impact will that have on computational requirements, on network throughput? Will that reduce or increase the amount of gas that we can do per block, that kind of stuff? And so we're not flying blind, right? I think it's very important to invest in simulation and emulation framework like this. And finally, I'll just briefly touch upon how ETH1X fits into kind of the overall Ethereum roadmap. This also comes from Alexei, so this is sort of his proposal for the first piece for storage management fees, what it might look like actually splitting this up into EIPs and rolling them out as hard forks. He's got about 15 different EIPs here with letters, and he's laid out, this is a bit outdated, I think. There may be a newer proposal, but in this particular one, 3 hard forks, maybe 1 here on the left side might be Istanbul. And you can kind of see, this is complex, but it's being broken down and done incrementally. And, yeah, we're looking at something on the order of 3 hard forks. And so this is going to be a large piece of, if not sort of most of, the bandwidth of the existing kind of core research and development kind of people who are not focused on ETH2 over the next few years, right? If you figure 6 to 9 months, let's say per hard fork, we're looking at 18 months, 24 months, something like that to kind of get to, beginning to achieve some of the goals of ETH1X. We have a meeting in a few days in Berlin focused on this. So pay attention if this is interesting, because you'll see a lot more soon about what this roadmap looks like and when you're going to begin seeing some of these changes and how to contribute to it. Thank you very much for your time.
Thank you so much, Lane. So you spoke about a couple of components, I think 5 components that you've spoken about. I'd like to ask you about sort of which part are you personally working on, and how do you see that prioritizing in terms of the roadmap development?
Yeah, no, that's a great question. So personally, I'm working on the Ewasm piece as part of the Ewasm team. I'm most excited about this piece because a lot of the other pieces we talked about, like bounding state, are sort of taking things away from Ethereum developers and Ethereum users and saying, we haven't been charging you enough, so we're going to begin charging you more. Ewasm is much more about sort of carrots rather than sticks, right? And so saying, hey, we're going to give you, an amazing new framework, an engine where you can build smart contracts in all sorts of different languages and use a lot of existing tooling. But having said that, the other pieces are very important as well.
Great. Thank you so much. And so you mentioned that you'd be talking about the roadmap in Berlin sometime?
Yes, so check out the Fellowship of Ethereum Magicians forum. It's ethereum-magicians.org. There's a host of information there, proposals. There may still be time to slot in. If you're interested in presenting an EIP, you don't have to be there in person. We're going to have remote participation as well. Just discussing the Istanbul hard fork roadmap as well.
Great. Thank you so much, Lane.
Updates there. Thank you.
Great. Thank you.